I think many of you have already been involved in the Spectrum project in one way or another. But the project director, Sergio Andreozzi from EGI, will quickly review what Spectrum is before giving the floor to Eric Wolf from CERN, who will present the first version of the technical blueprint for a compute and data continuum. And then to Xavier Salazar from EGI too, we will present the SRIDA. After these three presentations, we will answer a few questions, and then I will explain the next steps in the consultation and show you how you can get involved. Before going into detail about these two documents, Sergio Andreozzi, the project director, will give a brief overview of the Spectrum objectives. So, Sergio.
Thank you, Valentin, and welcome everybody. I will give you a quick overview on the Spectrum projects and where we are today, also in the timeline of this execution. The project has been designed to address an important challenge being faced by big science, connected to three large scientific instruments. Two of them, which are the high LHC and LOFAR, are going through a major upgrade, which will bring in new technology that will increase the quality of observations that can be done on the area of high energy physics and radio astronomy. And the third one, SKA, is a newly built flagship instrument in the area of radio astronomy. These three instruments will push the boundaries of current big science to new scale, new volumes, new velocity of data and variety. And this will push the boundary in the order of magnitudes on the data produced, also on the not only on the volume, but also on the velocity that need to be processed, that require, for instance, that data need to be analyze in real time, also to understand what to store for further processing and what to drop because it's not interesting. And also the variety will have many more sources of data that requires to be correlated, analyzed, and so on. This is bringing new challenges for current digital infrastructure for research. And that's why the project was created. The project was created to bring together the stakeholders from both the science side and the infrastructure side to understand how we can approach these new challenges, what is the current status of technology, of the infrastructures in Europe, and what could be the future directions to have also joint approaches, optimize the resource use, and achieve more alignment of efforts between the different organizations contributing to these big challenges. The project started in January 2024 and will finish June next year. So we are in the final phase of the project. And in the first part of the project, one of the approaches was to establish a community of practice to engage experts from the community, both from the science and the technology sides. And also he produced in the first part of this year, three foundational pieces of work. One is a compendium of use cases. Second one is landscape analysis. And the third one is the access policy recommendations to move towards more interoperable access of infrastructures. This foundational work then is being used to develop a strategic research innovation deployment agenda, technical blueprint for compute and data continuum, for which today we will get highlights on the public draft that has been released for public consultation. And the final version are expected in the second quarter of next year. The organizations involved into the project are from the scientific side, we have CERN and INFN for high energy physics. Then we have Astron representing the LOFAR telescope, and then CNR, Observatorio Quadro Azzurro, with support of Enovia Innovation for SKA. On the infrastructure side, we have EGI for HTC and cloud. And then we have Asafet infrastructure. And then we have ULISH, European Computing Center, CINECA, and SURF as national facilities covering the spectrum of cloud, HTC, HPC, and also some of them, they also have quantum projects in place. The approach to the project, as I mentioned, is more here. I am describe a kind of approach in terms of methodology. I mentioned that we use a community of practice to engage more than 60 experts from the community. So far, we create a foundational work with analysis of use cases, access policy recommendation, and landscape of existing infrastructures. Based on this knowledge, we have been analyzed, okay, what are the gaps that we can identify, the requirements, the current technologies, and then we're trying to understand how, which direction we could take for the future. This future direction is being synthesized in two main documents, which are kind of two sides of the same coin. The technical blueprint, which represent more the technical view on this computer and data continuum for data intensive science, and the SRIDA, which represents more the strategic and policy side. The community of practice in the first phase has been used to support the project to provide the knowledge. Then, as we are more moving into formulation of direction, is being used to validate this knowledge. And today also is an opportunity to ask for this validation more openly to the all set of stakeholders. And once the project will be over, the community of practice will have the, let's say, the role of taking the results into their own organizations and try to promote them for adoption. A quick highlight on the current results of the project. The community of practice is structured at the moment in 6 working groups. There is a knowledge base which is publicly accessible, and working groups are still open for additional members, if any of you is interested in joining this work. The compendium of use cases addressed 14 science cases, and 6 of them were more in the energy physics, 5 in the radio astronomy, and then we have 1 in chemistry, 1 in meteorological science, 1 in neuroscience. The idea of the use case is to start from the scientific activity or experiment or work that need to be addressed, and then to drill down into, okay, what are the technical implications and needs to support this science research. The access policies addressed the challenge of having heterogeneous infrastructures managed by independent institutions with different access policies. And if you want to build a continuum, then we need to understand also, we need to try to harmonize or keep the access policies in a way interoperable, in a way that it will be easier for research communities to use different infrastructures in a coordinated manner. So gaps were identified with a number of recommendations. And the last piece of work was the landscape analysis, who analyzed flagship European digital infrastructure that support science, trying to understand what are the current capabilities they have, services, and to derive a bit of insights for the future work. All these results have been published in June this year, and are available for consultation. What we're going to see today is the public draft of these 2 parallel tracks. The technology track leading to the technical blueprint has created a map of capabilities needed by a computer and data continuum. And the first of the capabilities was also an assessment of current technology being available, and a number of future activities have been identified with identified actions. In the second part of the project, we will also work on evaluating how these capabilities align between the scientific communities in terms of requirements or decisions for technology and so on. The strategy track, on the other hand, identified a number of top-level priority areas that require actions. We will see there will be 13 of these priorities. We have initial sketch of investment areas. These investment areas will be further developed in the first quarter of next year, based on the validation of the priorities that will come through the open consultation phase. And then we'll identify policy alignment with other European flagship policies in the area of digital infrastructures. I conclude with the introduction of the project, and I will hand over the stage to Eric for presenting the technical blueprint. Thank you.
Thanks a lot, Sergio. Just before letting the floor to Eric, a quick reminder that if you have any questions, you can write them in a Q&A box, and then we will answer them at the end of this presentation.
Okay, thank you. So now I will introduce the first major output of the Spectrum project, the technical blueprint for a European computing data continuum. So where the SRIDA more defines the vision and the priorities, the blueprint focuses more on the technical capabilities, the activities, and the concrete recommendations for future developments. So I want to start a little bit with the goals of this blueprint. So we basically have three primary goals. First, we try to identify key capabilities that are needed to enable an interoperable computing data ecosystem. Second, we integrate requirements from both the energy physics and the radio astronomy communities. And we try to capture the common needs, but also the domain-specific constraints that these communities have. And third, we provide actionable recommendations for future infrastructure design and for national and European funding programs. Now, this work does not start from scratch. We rely on input from work previously done in the Spectrum project, such as the insights and perspectives from the Spectrum COP, the Community of Practice, and the results from the survey that was carried out within the Spectrum COP. And we also rely on the detailed analysis of scientific use cases, the infrastructure landscape study, and the gap analysis study that was done in the first phase of Spectrum. And of course, we have developed the blueprint in parallel with the SRIDA and the priority setting and strategic direction developed as part of the SRIDA. So together, we hope that this preliminary work ensures that the blueprint is grounded in real-world requirements. So the development of this blueprint was led by CERN and CNRS and has been created in tight collaboration with the entire Spectrum consortium. And we're now releasing the first public draft of the blueprint, while the final version will be released in Q2 of 2026. And the reason for this timeline is to allow for both the SRIDA and the blueprint to incorporate the views of the wider HEP and ARIA communities, and to provide a coherent set of recommendations at the end that are well rooted in the communities. Now, the blueprint is structured into 5 main chapters. So we open with an introductory chapter with some background information and a summary of the preliminary work. Specifically, this is describing the work done in the Spectrum community of practice, the analysis of the use cases, and the landscape and policy recommendations. And this forms the foundation for the rest of the blueprint. Then we have a chapter where we address sustainability, which is, of course, a major cross-cutting concern for long-term scientific infrastructures, projects, and experiments. Then we have chapter 4, which is sort of the core of the document, where we talk about technical activities and recommended actions. And this is where we highlight what we believe are the main technical activities that we think are needed and the steps necessary to implement them. Finally, we have an annex which provides a capability map for the computing data continuum, and this is basically a structured way to get a good overview of the capabilities we think are required to realize the blueprint. So on this slide, you can see the full capability map. So what we have tried to do here is basically to identify the core capabilities that any federated cross-infrastructure ecosystem must provide if you want different computing data centers and research infrastructures to work together in a nice and coherent way. So each of these colored blocks represents one capability or one capability area where each of the concrete areas inside the boxes are functions that the continuum supports. So on the left, we have these vertical pillars: resource federation, monitoring, observability, and security and trust. And these we put them vertical here because we think they span across all the other capability layers and need to interact with all of them. Then on the right, we have these horizontal capability layers, which go from AI and ML applications to workflow orchestration, software distribution and execution, and finally the sort of underlying compute and data resources. So here, this is where the scientific workloads actually run across the compute and data continuum. Okay, so now I'd like to focus and go into a bit more detail on the technical activities and recommended actions that we put together. So I'll go through 8 of the most important activities here, but the document has that it describes more gaps, requirements, and recommendations. And you can have a look at the full document if you want to dig deeper and get an even more comprehensive view. So the first activity is standardization of interfaces. So one of the largest obstacles to integrate computing sites into HEP and RA workflows is the heterogeneity of the job submission systems and the APIs. And in order to address this, we recommend to adopt common interfaces. Ideally, these should be aligned with the UHPC Federation Platform, the AFP. Well, this is to allow applications to run seamlessly across different compute infrastructures without being without costly and time-consuming ad hoc integrations for each individual site. Now, the second activity we called infrastructure co-design. So we believe that it's very important for scientific communities, especially HEP and RA, to be involved early in the design of future HPC systems, because requirements such as the network and storage requirements or the requirement for double precision computing or what sort of hardware accelerators are available can't be addressed after procurement. So therefore, we think it's important that HEP and RA engage with UHPC and national funding agencies in a structured way in order to ensure that the scientific requirements can influence the system architectures. And then we have software portability and maintenance. So we've seen, of course, that many scientific codes were designed for CPU-only systems and are often not easily portable to GPUs, FPGAs, or other accelerators. So here we recommend to review code bases for accelerator readiness. and launching projects that use portable and modern frameworks. And this is important because we want our scientific workloads to be able to efficiently use the HPC systems of the future. Okay, moving on to the next set. So we have data management and network performance. So of course, scientific data volumes continue to grow, and there's a perceived lack of long-term storage and limited bandwidth to compute sites. And we think that there's also a lack of standardized high throughput data transfer services across HPC and HEC infrastructures. So in order to address this, we propose joint data challenges between SRCnet, WLCG, and compute centers to test data movement and data transfers at scale and identify any architectural constraints that may exist. Then we have workflow adaptation and optimization. So currently, workflow management systems need a lot of site-specific glue in order to run on HPC. So we need a more standard way to do things, some sort of integration layer that lets workflow systems submit jobs natively to HPC schedulers. And we think this would significantly reduce the operational overhead for both users and sites. So basically, this is about connecting existing workflow systems to HPC resource managers. Then we have security and AI. So AI systems vary widely across compute sites, and this fragmentation is again a major barrier to consistent access and interoperability. So here we recommend to have some sort of federated AI framework where users can authenticate once, ideally, and then access multiple facilities securely. And this should ideally also include things like interactive use cases, automated workflows, service accounts, and long-running unattended workloads. Okay, moving on to the last two. So first we have AI and ML integration and computational trends. So we see that AI workloads are growing rapidly in HEP, and it's used in RA as well, and is getting ever more important for the future of science as a whole. At the same time, AI accelerated hardware is often optimized for low precision arithmetic, and this is not always suitable for the traditional sort of non-AI based workloads in science. So here we recommend to support the use of AI in science by integrating services like distributed training and inference and model management directly into the compute and data continuum. But at the same time, we think it's important that future systems also maintain strong double precision performance. And finally, related to this, we also think it's very important that the domain scientists are given training and support to learn how to use these new methods and AI technologies effectively. Last but not least, we have long-term resource provisioning and sustainability. So basically, current HPC applications are typically short-term and project-based, which is not always compatible with the multi-year or even multi-decade life cycles of large scientific collaborations and experiments. So to address this, we would recommend to have some sort of multi-year allocation models and to investigate renewable allocation mechanisms that map more naturally to the scientific roadmaps of HEP and RA. And with that, I will leave the word to Xavi, who will present the second major output of the Spectrum project.
Okay, so thank you very much, Eric. So here's the other side of the coin. So Eric has explained the technical challenges and recommendations, and so the strategic research, innovation and deployment agenda is taking those technical challenges and recommendations and is trying to translate them into political actions and policy-driven activities. So this SRIDA work has been compiled by the Sergio Andrets and myself as main editorial team. But noteworthy to say, we have been so far asking for the collaboration of the whole consortium and the community of practice in order to develop the content and the specific parts of the content of the SRIDA. So at the end of the day, it's a joint collaborative work between all the project participants. So we are delivering today like the first version of the public draft, which would be subject of the consultation so that we can fine tune it and we can align and validate like the initial outcomes. And by the end of the second quarter 2026, we expect the final release of the SRIDA. So as with the technical blueprint, we are also presenting the table of contents. And yeah, it starts with a general overview introduction with the vision and strategic goals, as it was explained by Sergio at the beginning. And the integrated strategic foresight framework and methodology that was also briefly introduced at the beginning of the presentation. And that it explains like how all the different evidences have been collected and how we have organized and involved the different partners and the different experts in order to get together like the whole content. Then we have a section on the strategic context and trends both on the European context and the landscape itself, like on a higher level or from a higher level point of view. So we have been trying to address six or the main strategic drivers that are like shaping or reshaping the whole landscape as the time is evolving. And then the core part of the SRIDA is the strategic priorities, as it was also introduced by Sergio. So these are the main priority areas that we have identified by the analysis of the different technical and non-technical recommendations. And we will, this will be the main focus of the follow-up presentation. As well, noteworthy to say, like as a consequence and coming from the strategic priorities, we have started drafting like the suggestion for investment areas and multi-annual roadmap, which at this initial version, we expect them to get validated as the priorities are validated with the consultation. So the final version of those will be delivered in the second version. Okay, but it serves for getting an initial flavor. So getting more into depth of the priorities, how did we develop them? So we have prepared a template so that the different spectrum players and experts could work out the different areas. So once we have decided on the different priority areas, we have distributed like this template that has three parts or three main parts. So the first one is the strategic rationale and how like the different evidences are backing and are justifying the need of having this priority, including both like from the technical and the higher level European policy side. Then the second part is the target outcomes and the impact assessment. So it's like what do we expect that would be needed, or would be the expected outcome, like in a mid and longer term of these priorities, and the impact that will produce or that they will generate. And the last part is done on the implementation side. So like what would be the different actions that should be done, both by the different stakeholders in the mid and longer terms, okay, and including like what would be the expected resources. Okay, so getting a bit more into depth into the content of the different pillars. So you will see like many of those are like directly taken from the or are shaped by the technical blueprint, taking into account that within the SRIDA, we try to address them from a policy point of view, even though there are like strong overlaps between them. It's obvious. So we decided to put them into 4 different pillars. Like 2 of them are more technical, like the architecture and interoperability and the software and science enabled, like they are like addressing a lot of the different challenges that were addressed by the technical blueprint. And then there are 2 that are like cross-cutting. That's on the policy, trust, and governance on the one side, and on the other side, the human capital and the human aspects and the social responsibility that it would be needed. And we have defined 13 different priorities along those, and I will get into detail in the next slides. So on the first pillar, as I was saying, like this is the cross-cutting transversal domain or area in which we need to define governance or the cross-infrastructure governance. So one of the gaps that we have been identifying, or that it's well known over the communities, is the fragmentation. So there are like many different thematic resource infrastructures, pan-European infrastructures, and despite like the efforts in the last years or in like historical efforts of bringing them together, so there is still like some room for improvement. So we are expecting and we are recommending like to deliver like and to structure better the coordination mechanisms. And for instance, like by the establishment of a coordination forum that would help to coordinate across the different stakeholders. The second one is touching more the technical side as well, like how the resources are allocated and are decided. So there was, as it was also explained by Eric, there is like this mismatch between like how historically the allocation cycles have been established compared to the needs of some experiments that are like longer lasting, like multi-year experiments. So from a strategic point of view, the instruments should also be aligned. So it's like for coming up for different access mechanisms, it needs to be triggered from a higher level political discussion that is able to bring together like the different time scales of the experiments and the how the compute capabilities are assigned. The third one, and as well coming up and insisting with this fragmentation, is also the access, the AAI, the Federated Identity, Security, and Trust that is needed, and that it's not yet coherent across like the different stakeholders. So there is still some work to align and to get like this seamless federation of the authentication systems that would also enable to address like the scientific community's needs. And as well, this would also include like some automatic long running workflows, as it was explained by Eric. Getting more into the technical pillars, so the architecture and interoperability across sites and across systems. So we have like a major trend from the technical perspective that's the systems are becoming more and more heterogeneous. So we need to incorporate like the traditional CPUs, but also like the accelerators and the accelerating units to tackle all the AI and acceleration problems. And in the future, we will also need like to integrate like the quantum quantum compute capabilities, and probably other like systems like neuromorphic or other types of systems that need to be able to FPGA based or that need to be able to interoperate. So there is this need of an unified interface, and that would need to facilitate like the access or the overall access to the different types of resources in an easier way for the scientific communities. Getting into the data, so we have also seen like this is one of the major challenges that we will have or that the scientific communities will have, as it was explained. So we will need to have like a exabyte scale data to be processed and to be coordinated, and this will need like some policy coordination as well into like setting up like the different systems that would enable all this federated fair data management and the automated data movement between the different sites. And getting closer to the software, that will be the next pillar, but somewhere between, so it's the orchestration and workflows. So, and again, getting with this challenging idea of not having unified systems, so that we need to go to or to try to reinforce the idea of getting like interoperable workflow orchestration, so that the different softwares can also be ported and be operated across the different sites. So this would be like from an orchestration point of view, like that it's needed from the infrastructure side, like the orchestration offering. And we jump to the third pillar, and that's coming on the software, and it's the other side. And as seen as science enablers. And the first one, so it's a mega trend. So there is all this AI machine learning wave that needs to be tackled, and that in many senses, so it needs to be addressed, or needs to be started to be addressed by the scientific communities that have been moving traditionally from the traditional simulations, and there is this need to train the communities and to get like the different AI capabilities to be able to be leveraged. And for doing that, we also need like a fully working infrastructure that is available to the communities. And then the other ones, and I will explain them all together because they are like showing like similar phases on the software. So it's like all the scientific software that it's generated and produced. So we need it to be portable, to be reproducible, and to be sustainable over time. And this also covers like the challenge that we have all these multi-year experiments that are long-lasting. So we need to ensure that those software components are moved or are able to be moved across sites. We need to be able to ensure that both software and data can be used for validating the science and to follow like the open science requirements. And this will ensure as well like having sustainable over time of the software. And this not only includes like the technical sustainability, like to ensure that there is a maintenance, but also like a sustainability over time that they can be adapted to the new systems and that they can be further developed over the time upon the needs of the scientific communities. So as a main recommendation, so we need like open science to be in the core of the policies, okay, and to keep on like reinforcing those open science best practices. And this should include like software repository with software management plan, and also like the whole data sets to be fair. Last but not least, so it's the human capital pillar. So this is the other like side of the governance side. So we are working and we are collaborating with communities, with scientific communities. So we need to ensure that these communities are strengthened, that they collaborate, that they keep on working together. So we need also a structured approach in order to structure this community and to help the community to collaborate. And then together with the community and the others complementary, so how can we support this? So we need like to provide like an upskilling schemes, training, proper training, like not only on the technical or different technical capabilities that need to be incorporated by the different actors, like the different scientific communities. And so it's not only like the technical training on the new systems and the new like software paradigms, AI, as I was telling, but it's also like on non-technical, but also very important aspects like ensuring like that they follow the open science best practices, including like the verification of data, the how to deal with the software management and all this. As in general, so there is this need of research software, establishing a career for a research software engineering. That would include like a recognition. And then the other like big aspect that was also highlighted by Eric in the technical blueprint, and that it has also a very strong social responsibility factor. That's the environmental sustainability. So the growing systems, we need to ensure that they are like efficiently used in terms of energy efficiency. So from a policy point of view, like how should we foster this? So we need to introduce and we need to put at the core the fact that the new systems that are procured, that are like set in place, they incorporate like sustainability metrics. So for instance, like for the high energy physics domain, there is this HEP score per watt that it's frequently used in order to assess like the efficiency for like the codes and the different applications on the high energy physics domain. And these having such metrics would help as well to contain or to address like this environmental sustainability needs. So these were the 13 pillars. So I will hand the 13 priorities, and I will hand the presentation to Valentin to close and to teach everyone like how to how to contribute and how to help us. So thanks a lot.
Thanks a lot, Xavier, for your presentation. So just before moving on to a short question and answer session, if you have any question, I will briefly remind you of the next steps in the project and above all, how you can give your opinion on the two documents during the consultation period, which begins today and will last until the end of January. So let me now outline the next steps. So as I said, the public consultation opens today. From now on, you can access the documents on our website and send us the feedback until the end of January. Once the consultation closes, we will analyze all inputs and try to refine the document, the SRIDA, and the technical blueprint accordingly. Then in April, we will finalize the internal versions of the SRIDA and the technical blueprints and prepare them for public release. And all the documents we presented today are accessible online via this link. So if you would like to stay informed about the event, you can visit the Spectrum public consultation page on the project website. We have enough time. I can show you what you will find on this page. So by clicking on this link, you will access various information. The most important feature is this button in green, leading to the survey, which will allow you to access the technical blueprints, the SRIDA, and today's presentation, just right here. Or you can find the documents by clicking on the second buttons with the direct link, direct to Zenodo. On the survey, you can answer as many questions as you wish, depending on the time you're available, of course. Because apart from the first section, none of the questions are mandatory. Finally, on this page, you can also have access more information about the community of practice that we set up last year. We organize monthly presentations on topics related to HPC, high energy physics, and radio astronomy. So there is this knowledge base publicly accessible without any registration, where you can find the latest information about the community of practice. And via this page, you can check all the previous presentation. And if you want to join the community of practice, you can send us an email via this link. We will also consult the working groups of the community of practice during the consultation phase. Last thing, you can also have access to our LinkedIn page, which we update regularly, so don't hesitate to follow the Spectrum Project LinkedIn page. Of course, you can find the link on the chat, and participants in this webinar will later receive the link to this page, so they can access all this information. The final versions of the SRIDA and the technical blueprint will be presented during the Spectrum closing events scheduled in Brussels on the 3rd of June 2026. So this event will be an opportunity not only to reveal the final outputs of the project, but also to bring communities together, exchange perspective, and discuss the steps to be taken after the end of the project. So please save the date, and we look forward to welcoming many of you there. Now we will stop the recording, and we have just the time